Hello, welcome back to AMT 181 NavCom lecture. If you are live on this right now, please type in the chat and let me know that you can hear me. And I will get started. Okay, well, I don't know if anyone can hear me, but hopefully you can. So I am going to go ahead and move on. Today we are going to be covering VOR. So we'll be talking about radio navigation and VOR, and that will be all that we're covering today. I want to tell you guys that I have posted a new schedule as far as lectures and reading assignments go. I posted it in an announcement on Canvas. I also posted it in the module under week 3 under the tab week 3 slides for Tuesday. I'm going to bring that up so I can just show you guys where it's at. Okay, so I made an announcement here. I've created a new schedule. There's a link to the document here. When you first open our course, you'll come to the home page, which looks like this. We're in week 3, so I also posted that document under week 3 slides Tuesday for today. So when you guys receive these slides tomorrow, you will see both of these things there. So if you're interested, take a look at that. There's an updated version of basically what I will be covering in lecture each day and the corresponding pages that are student reading. So today we're going to be covering VOR, talking about radio navigation aids. VOR is a radio navigation aid. So radio navigation aids supply the pilot with intelligence that maintains or enhances the safety of flight. Radio navigation aids are avionics devices, the repair of which must be carried out by trained technicians at certified repair stations. That is talking about for avionics equipment. If those things need repair, they need to be repaired by certified repair stations, specifically for whatever that repair station is rated for repairing any type of avionics equipment. We as AMTs are not going to be doing any repair of avionics equipment. What do we do? AMTs are responsible for installation, maintenance, and proper functioning of the following: electronics, antennas, displays, any other associated devices with, as far as this class goes, with navigational and communications equipment. But we do not perform repairs. VOR navigation systems. This is a picture of a VOR. VOR nav systems were constructed after World War II. It's a very old system that's still used today. It's still very effective and still current for pilots to use. It consists of thousands of land-based transmitter stations, which are VORs, which is what this is in this picture. So there are thousands of these. Anywhere where planes fly, there are VOR stations. These VOR stations communicate with radio receiving equipment on board aircraft. There's a few other terms in association with VORs. We have TVOR, which stands for terminal VOR. This is a VOR, ground VOR transmitter unit that's located at an airport. So it is there terminally. It's a permanent station for it at that airport. We also have the term TACAN, which stands for Tactical Air Navigation Systems. This is a term used by the military. It's a navigational system that operates similarly to the VOR system, just a military version. And VORTAC. VORTAC is just a combination of VOR and TACAN. These are sites where VOR and TACAN transmitters share a location. The position of all VORs, TVORs, and VORTACs are marked on aeronautical charts and include the following information. That includes the name of the station, the frequency to be tuned in order to use the station, and a Morse code designation for the station. And this is an example of a map of your VOR. Here's your VOR again. This is a VOR DME used together, symbol for your VORTAC and symbol for your VOR. The VOR uses VHF radio waves. And if you remember a few lectures ago, we talked about what megahertz VHF operates on, and the VOR operates on VHF, which is 108 to 117.95 megahertz. You will want to know that. It's separated by 50 kilohertz between each channel. This keeps atmospheric interference to a minimum, but limits the VOR to line of sight usage. To receive VOR VHF radio waves, generally a V-shaped, horizontally polarized bipole antenna is used. Remember, we talked about all of these things in the last lecture, that our antennas are polarized, and we have a few different types of antennas that can be used. And these are some pictures of some different antennas. Here's one on the tail of an aircraft. A VOR transmitter sends signals out 360 degrees from the unit, from the VOR, and are used by aircraft to navigate to and from the station with onboard VOR receiver and display instruments. A pilot is not required to fly a pattern to intersect the signal from a VOR station. So a pilot does not need to fly in a specific pattern to intersect the signal. The radio waves are received regardless of the aircraft's direction of travel, as long as the aircraft is within range. That's within range of the VOR. The VOR transmitter produces two signals that are used to locate itself in relation to the ground station. One signal is a reference signal, and the other signal is produced by electronically rotating a variable signal. The VOR receiver in the aircraft deciphers the phase difference, and determines the aircraft's position in degrees from the VOR ground unit. Most aircraft carry a dual VOR receiver, sometimes part of the same avionics unit as the VHF comm transceivers, known as NavComm radios. Large aircraft may have two dual receivers and even dual antennas. VOR receivers can also be coupled with instrument landing systems, receivers, and glide slope receivers. A VOR receiver interprets the bearing in degrees to or from the VOR station. The receiver produces a DC voltage to drive the display of the deviation from the desired course center line to or from the selected station. The receiver decides if the aircraft is flying toward the VOR or away from it. Older aircraft are often equipped with a VOR gauge, dedicated to display only VOR information. This is called an omni-bearing selector or a course deviation indicator. The CDI, the course deviation indicator, linear indicator, remains mostly vertical. It can move left and right across graduations on the instrument, and this shows deviation from being on course. Each graduation represents 2 degrees. So this indicator assists the pilot in knowing if they're staying on course and how well they're staying on course. The OBS knob, when in range of a VOR, the pilot rotates the OBS until the course deviation indicator centers. The OBS can be rotated to 2 positions where the CDI will center. One position produces an arrow in the to window of the gauge, indicating that the aircraft is traveling toward the VOR station. So if you get an arrow, a little indicator with that says to, in the to window, then the gauge is indicating that you are flying toward the VOR station. The other selectable bearing is 180 degrees from this. So from the selection of flying to the VOR, exactly 180 degrees from that position, you would have an arrow displayed in the from window, indicating the aircraft is moving away from the VOR on the course selected. So definitely know what that means. You need to know what happens when you're flying away from the VOR, what signs to look for, how that operates, and same thing flying to the VOR. The pilot must steer the aircraft to the heading with the CDI centered to fly directly to or from the VOR. The displayed VOR information is derived from deciphering the phase relationship between the 2 simultaneously transmitted signals from the VOR ground station. When power is lost or the VOR signal is weak or interrupted, a nav warning flag comes into view. VOR navigation information has been integrated into other instruments' displays over time. This includes radio magnetic indicators, RMIs, HSIs, EFIS displays, flight management systems, and automatic flight control systems. Over time, as avionics has improved and we've been able to combine some systems, you'll now find VOR systems integrated into these other instruments. It is common at VOR stations to combine the VOR transmitter with either of these pieces of equipment as well, distance measuring equipment, DMEs. They can also be combined with non-directional beacons, NDB. This includes ADF transmitter and antennas, automatic display functions, transmitter and antennas. When used with a DME, pilots can gain an exact fix on their location using the VOR and DME together. So when we can use the VOR and the DME together, the pilots can have a better and more accurate fix on their location. They can get it exact. VOR receivers are operationally tested using VOR test facilities. These are called VOTs. VOR test facilities are located at numerous airports. There are specific points on the airport surface that are given to perform these tests for VORs. So you'll have a specific VOR testing area at an airport. Most VOTs require tuning to 108 megahertz on the VOR receiver and centering the CDI. The OBS should indicate 0 degrees showing from on the indicator, or 180 degrees when showing to on the indicator. Remember, you'll have a little arrow that points to one of these, from or to. If an RMI is used as the indicator, the test heading should always indicate 180 degrees. Some repair stations can also generate signals to test VOR receivers, although not on 108 megahertz. An error of plus or minus 4 degrees should not be exceeded when testing a VOR system with a VOT. An error in excess of this prevents the use of the aircraft for IFR flight. So if there is an error in excess of this, it must be repaired, or else it makes the aircraft not usable for IFR flight. So that's it for today. We're just discussing VORs. Don't forget to take the quiz by midnight tonight. It's just going to be on VOR systems, anything that was covered here in the slides. And again, I posted a new schedule for the semester as far as lectures and testing goes. You'll notice on that schedule, we're only going to have 2 tests in this class. So you still have quizzes every day that we have lecture, but we are only going to have a midterm and a final. Because this class is only 8 weeks, it's tough to put in any more tests. Not that you guys want more tests, but we're just going to do a midterm and a final. So keep that in mind with your study habits. And, we may not be having a lot of tests, but this information does still need to be reviewed. And that's it. I will see you guys in lab. For anybody that's on, I don't even know if anybody's on here, but if you have questions, you can type them in the chat. And that's it for today. The slides will be available tomorrow on Canvas.